Greetings, everyone. Welcome to the Drobo Broadcast Network. My name is Mario Blandini at Drobo, and today's topic is disaster recovery, specifically in a virtualized environment. Most small businesses have looked at virtualization as the way they manage their applications. And from that foundation, there are some opportunities to use that same foundation for disaster recovery. So we're talking about approaches and architectures for replication from a smaller IT environment perspective. And with us today is guest expert Lee Dilworth, who's a principal system engineer with VMware. How are you doing today, Lee?
I'm great. Thanks for inviting me along.
Well, I'm happy to have you on the podcast today because your sessions last week at VMworld Europe were absolutely packed. I couldn't even get into the first one, but I know folks really enjoyed those sessions. As we go to the next slide, today's abstract, I think everyone understands virtualization is pretty commonplace, and you're talking with customers all the time about how they use that same infrastructure to achieve their disaster recovery objectives, but do so in a way that's not too complex and is also not so costly. And I'm happy to talk about some new things that exist with VMware, vSphere 5, and Site Recovery Manager, which can help folks out. Maybe you could tell us a little bit about yourself. You've been with VMware for several years now, and you center your practice in disaster recovery, correct?
Yeah, that's correct. So I joined VMware back in 2005, so I was one of the first employees in Europe. My focus back then was post-sales implementation. So I used to go out and do a lot of disaster recovery projects back then, based on scripting, to be fair. Back then we didn't really have any integration with storage platforms at that time, so a lot of disaster recovery was either reliant on manual runbooks or documented processes, or in some cases we could try and script specific elements to try and remove the natural kind of human error aspect of VR. So I've kind of seen both sides of the coin, if you like, the kind of the pre-automation world and the kind of the automation side of it.
Well, as we go to the next slide, that's a perfect transition because for small and medium businesses, scripting and manual runbooks are probably not really practical, and certainly cost has historically been an inhibitor from a practicality standpoint. But as we show in that image in the upper right-hand corner, disasters can happen, fires, floods, and other things. So the concept of having the ability to move an application off-site and get it up and running in a different location is a requirement even for small businesses. So can you tell us a little bit about how virtualization's helped to make it more practical for small businesses in terms of disaster recovery?
Yeah, I think the key thing is obviously encapsulation. So everybody out there that's listening that's virtualized servers and they now have them running as virtual machines. Ultimately, those machines are now represented by a set of files sitting down on the storage platform. Now, obviously, once you have that entire server represented by a set of files, if you can replicate those files, you're essentially replicating that server to a remote target site. Now, if you compare that to maybe the physical version, when we used to do things physically, if you wanted to have DR, you would typically have a server, and then you'd have to buy another server and place that at a distant location, and then come up with a technique to try and keep the two in the sync in terms of data and BIOS and firmware and patches. And, that would be hugely complex and time-consuming. If you can just replicate the server image and transport it to a target site, then at the target site, you simply need to fire up that image on your virtualization platform like VMware, and that server will just run in the same way that it did at the primary site, in a nutshell.
And Site Recovery Manager from VMware then is that orchestration piece that allows you to manage this process from a central place, and it's essentially where your recovery plans would exist, replacing what would be your runbooks and your manual scripting.
Correct. So there's a lot of elements to SRM, as we call it, Site Recovery Manager. But in terms of a one-line description, its task is to basically ensure a successful migration of virtual machines from one data center to another data center. And traditionally, the way that we've done that in version 1 and version 4 is we've relied upon storage array-based replication to do the heavy lifting, if you like, the transportation of the virtual machine disks from A to B, has always been done by the SAN layer. So that has kind of meant that if you didn't have storage SAN replication available to you for whatever reason, either your array didn't support it, or you haven't bought it, or you had different types of SAN at either site, and you didn't have a way to get from A to B, do the conversion, then you were kind of excluded a little bit from being able to use SRM because you didn't have some of the component parts that were required. And we'll touch upon as we go through today how we've changed that with SRM version 5 and vSphere 5.
Well, as we go to the next slide, we're comparing different approaches to replication, and you mentioned disk-to-disk replication being the way previously that most users would do that. There are other options out there, and some of them are software-based replication and SAN appliance. Rather than contrast these specifically, I want to ask you a question about recovery point and recovery time, because those are terms, RPOs and RTOs, that are often come up. And for a smaller organization that's new to DR, they may not understand those completely. There are pros and cons to both of those metrics depending on which approach you use. But in general, from a small business perspective, how should they be thinking about recovery point and recovery time objectives?
So, I mean, basically, at the high level, the recovery point objective is all about, I guess customers just refer to it as, what kind of data loss is acceptable to me in the event of a DR event. Do I want to have zero data loss when I cut over, or in terms of am I going to be reliant on synchronous replication, so everything has to be replicated to the DR site as soon as it's written to disk, or is my SLA such that I can be recovered successfully with an asynchronous technology where that might be combined with some kind of volume-based quiescing at the file system layer, so that every X number of minutes I have a consistent snapshot of that virtual machine, if you like, that's transferred to the target disk, where it might be X minutes old. So if I have a disaster at 3 o'clock in the afternoon, the last asynchronous update was 1 hour ago, 15 minutes ago, however long it was. So I always roll back to that point in time. So that's kind of your recovery point objective. How far are you going to go? And as you show in your slide, as the requirements go up, so do the costs. So if you want synchronous replication technology, it comes at a price. So you have to really be very clear on what your actual SLAs are. And for many customers out there, even enterprise, sized companies, the large global, enterprises out there, even many of their applications aren't replicated synchronously because the SLA might dictate that, a 1 hour asynchronous thing is good enough, or 30 minutes, or 5 minutes, or 15. So you have to kind of categorize your application.
Well, it makes a lot of sense, Lee, because the most important thing is to protect the applications and get the ability to restore them quickly. In the case of recovery time, how quick can you get that back up and running so the operations are back up? Most people just want things back up very quickly, and traditional backup and restore certainly doesn't allow you to have recovery points and recovery times that are anywhere near this close. So for a lot of small businesses, it's likely that using software-based replication is a great fit because it's lower in cost, as we'll demonstrate in our best practices approach here, can be a lot less complex and give them most of the same capabilities that a more expensive solution would. You're just having to make some, I hate to use the word sacrifices, but you can't have everything for free. You have to give a little bit back in terms of the recovery point. So we'll talk about that as we go through the presentation. I want to go to the next slide on the basic architecture. And we show here that there's a protected site and a recovery site, and there will be infrastructure at both sites. But with software-based replication, one of the benefits is that you do not need exactly the same storage hardware on both sides. In terms of the server hardware, though, I know that you can have heterogeneous data stores with the vSphere replication, Lee, but what about building out servers? Do you need a one-for-one mapping of all the physical vSphere servers that you have at your protected site at the recovery site? How should people think about the amount of infrastructure they need to buy for their recovery site?
So, basically, obviously, the infrastructure of the recovery site needs to be able to run the workloads that you want to fail over to it. So, in terms of capacity planning, customers today usually have active production of workloads running at both locations, whether that location be an office or a data center. There's production work running there. So, you would look at either site. You would work out how many virtual machines at either site would fail over to the opposite site in the event of their primary home location disappearing or going offline. And you would work out, the approximate resource utilization, things like CPU memory that those virtual machines would need. And then you would look at the host at the target site, and you would ensure that you have that available capacity to run those virtual machines. And things like SRM has the ability, as part of the failover process, to kind of shut down virtual machines as well, put them into a hibernated state. So if you're failing over from site A to site B, and site B is running protected production virtual machines, and it's also maybe running a dev environment, a test environment, for example, or some other kind of non-production virtual machines, non-critical workloads, as part of that orchestrated recovery, the system can suspend those virtual machines for you to make room for the virtual machines that are about to be activated as part of the failover process. And it will make room for them by putting the existing ones into a hibernated state to free up that CPU memory capacity. So you don't have to just go and buy N+1 hardware. You can kind of look at the balance, and you can work out what needs to be critically on in the event of disaster. Let's just ensure that we have enough space at the DR site or the ultimate site to run the virtual machines that live there and the ones that are going to come across. Because it might not be everything that comes across, and you always have to remember that. You're only going to recover the virtual machines that are critical to you to run the business.
Right. I think for small businesses, they're looking just to get the smaller number of those back up and running that are the most critical while they work on restoring their production site, because a lot of folks can't afford an N+1 sort of configuration. Going to the next slide, Lee, I want to ask you a question about simplicity, because I often get customers asking about DR, and certainly cost is one of those things that comes up as an inhibitor, but more often than not, it's how complex that it's perceived to be that keeps people from looking any further into it. Now, I'd venture to say that getting rid of runbooks for recovery and managing recovery in a familiar environment is important. The lack of understanding of storage-based replication amongst most small users that have never used it would be something that would be complexity they can avoid by going with a software-based replication approach. But also the ability to test things more easily and do planned migrations. Maybe you can talk about how SRM and how vSphere replication were designed to meet these specific needs for a smaller organization.
Yeah, I mean, the same applies no matter how big the organization. I mean, the key thing for anybody that's serious about DR is, the keep it simple approach. Things like reliability, robustness, repeatability. They are three key words for anybody that's serious about DR. And what SRM gives to customers of any size is the ability to have a pre-built workflow or number of workflows. You can have more than one, certainly, that can be executed when it comes down to it by simply pressing a button. So it doesn't matter who is left in charge of pressing that button. If they can log into the system, or they can call the workflow through an API, they can press the button, almost as we're showing in the slide there, the kind of the ETDR button. Obviously, it doesn't actually look like that in the UI. But it doesn't matter whether they're the person that built the workflow, the person that installed and set up the system. As long as they can use a mouse and press a button, that recovery will be re-executed in exactly the same way that the original guy designed it. And that same workflow can also be used to test the failover in a non-disruptive way. So you can actually test your DR workflow and logic even during business hours whilst the production virtual machines are up and running. But the key element is it can be done by anybody once it's in place. So once you've built it and you've tested it, if you happen to be the one that's on holiday, or you're out of the country and you're not around when somebody needs to press that button, anybody that's left behind can access and press it anyway. Or in this day and age, you could probably have the vSphere client on your iPad, and you could be sitting in a cafe on holiday in Europe, and you could invoke the recovery from there. So you can go to all kinds of different extremes.
Well, it'd probably be good to be far away from your disaster if you were really failing over for some sort of bad event. But a lot of folks really, from a migration perspective, are probably migrating more often than they're doing a true failover. And when the failover occurs, there's a lot of reasons it could happen, not just a disaster, but power outage and other sort of things going on. So I want to go to the next slide and talk a little bit about vSphere replication specifically, because it is, for those who have not understood it so far, a replication facility that's built into VMware. Maybe you can talk a little bit, Lee, about this new capability in VMware and what it provides in terms of the specifics around the replication and how granular this replication is per virtual machine?
Yeah, so I mean, vSphere replication is, in a nutshell, it's per virtual machine replication that's completely independent of the storage. It's part of SRM5 and vSphere 5, so you need to be on those versions to use it. It allows customers of any type, whether they have storage array replication or not, to be able to replicate virtual machines asynchronously between two locations. You can use it if the virtual machines are sitting on local disk in a tower server under somebody's desk, as long as that tower server is being controlled by a virtual center. You can select a virtual machine and you can replicate it to any target site that's also got a virtual center server in it, and you can replicate those virtual machines to any kind of disk that the ESX hosts at that location can see. So you can go from local disk to local disk, you could go from NFS to SAN, you could go from iSCSI data store to fiber channel. It really doesn't matter. As long as the ESX server can see the virtual machine, then we can replicate it to a target destination. So the purpose for, in terms of the SRM market, is it's designed to not only allow the people with SAN replication to be able to reach out to locations where they don't have SAN, but it's also designed for the small and medium customers who don't have any SAN replication to now be able to replicate their virtual machines and also hopefully use the benefits of SRM to enable them to perform successful recoveries in virtual machine operations.
And there's technologies built in to make that a replication very efficient. As we go to our next slide and talk about the SRM architecture with vSphere replication included, we'll see that logically there's a lot of elements there that coordinate together to provide not just the management of the virtual environment, but the management of the site recovery manager function. There are agents built into ESX 5.0, as you mentioned there, Lee, that provide the replication agent, and then this server function at the recovery site. We're showing here an example where you might have tier 1 storage in one site of any vendor, but you want to acquire storage at your secondary site or recovery site, which is not of the same type. It could be because you're looking for lower cost, or you're wanting to have something that is not the same and not using array-based replication. This VR server element that's on the right-hand side there, Lee, at the recovery site, is that a virtual machine or a physical machine, and what role does that play in the overall function of the solution?
So the VR server component on the right-hand side of the slide is basically it's a virtual appliance. So it's an appliance that we built. It's deployed via the SRM server as part of the install and config. And its role is to essentially act like a captures mitt, if you like. So its role is to receive the incoming, the easy term is snapshots, but we call them lightweight deltas internally in VMware. But they're basically the consistent disk images that are sent periodically from the protected site. So as the virtual machines of the protected site are being replicated at whatever schedule the customer selected, whether that be 15 minutes, 20 minutes, an hour, those snapshots will get sent across. They'll be received by the VR server. We only show one VR server in this diagram, but you can have multiple. And those VR servers will coordinate the writing of those deltas down to the target disks that are sitting in that Drobo unit there. And that will be done via the NFC service, which is inside every ESX image that we have out there. So that will be in charge of writing those down. The components are, may look, if you've never seen a slide like this before, fairly complex, but it is fairly simple. So you need obviously two sites. You need a virtual center server, which is just a virtual machine, one at each site. SRM server, again, just a virtual machine, one at each site. And then this is obviously SRM version 5, the virtual center 5 we're talking about here. You then simply deploy the appliances for vSphere replication, which is all GUI-driven and wizard-driven through the SRM UI. So you deploy the management appliance, which we show on the slides here as the VRMS. And then you deploy the captures mitt, if you like, VR server at your target site, the recovery site. And then it's literally right-click on the virtual machines and you're good to go from that point to start replicate.
Fantastic. We talk about right-clicking on the virtual machine and providing the setup. As we go to the next slide, leveraging vSphere replication, there's certainly cost, hardware, and bandwidth latency questions. In this solution, customers can deploy this solution for as little as $195 per VM, which is a lot less expensive than most people might think. It also supports your ability to use a heterogeneous storage environment, so lower cost storage. Now, in terms of the bandwidth and latency, you can set your RPO, which will be based on your available resources. So the shorter the RPO, the more resource bandwidth you need between sites. You can also do some initial copy seeding. So maybe you can talk a little bit, Lee, about the sizing of the network between two sites, because I think that's something that folks need to understand. How does that play into the decision of choosing the right RPO against the amount of bandwidth that you have available between your two sites?
Yeah, so that's like the $64 million question. It's the oldest kind of cliche in the IT industry. It's kind of the it depends answer, because everybody's environment is going to be different. Everyone's going to have different site-to-site links. Everybody's going to have different unique write rates in their virtual machines. So it is quite difficult to give an approximation of what the bandwidth throughput is required. The main kind of culprit for soaking up the bandwidth, if you just did things out of the box, would obviously be the transfer of the initial copy. If you imagine you're a small customer, you still could have 10, 20, 30, 40, 50, 60 virtual machines, each of which has 50, 60, 100, 200 gigs worth of virtual disk files. At some point when you start the replication going, you've got to get an initial copy at the target site. So you've got to kind of do that big lift and shift, if you like. Now, if you've got a fair latency, low bandwidth link, that copy could take quite a long time for all of those virtual machines. If you've got 50 or 100 gig virtual machines, the throughput could mean that you might sit there for quite a few days waiting for those initial copies to complete. What we allow customers to do with vSphere replication is to kind of pre-seed, sneakernet style, the initial copy. So you can literally export the virtual machines from their source location, and that's not kind of export them by removing them, but just literally copy them, almost paste them, if you like, to a removable drive, USB drive, that you could literally attach to the back of your laptop or your ESX host. Ship that drive securely to the target site or remote office, wherever it is. Import those virtual disk files from that device into a data store on the ESX host of the target, and you just copy the virtual machine folders into specific data stores, of your own choosing. When you then set up replication for a virtual machine, which you've kind of cut and pasted in that fashion, vSphere replication will look at the target folder you choose, and it will recognize the fact that there are disk drives already in that folder that seem to look like the virtual machine disk files that you're asking it to replicate. You corroborate that and you say, yes, they are the same, or they're more or less the same. The system will then essentially index all of the blocks in the virtual disk file at the target and the recovery site. It will take checksums of all of those. It will work out what's different, i.e. what has changed in the source disk that's different to this target disk that I've got. But the two could now be 24 hours old because it took that long to cut and paste them and send them off with a courier down to the target site. But now it can work out what's changed overnight, for example, and it just needs to copy the changes that have happened in that time. And then once that initial copy is finished of those changes, we've then got a consistent disk image to that point in time. And we can then start and replicate based on the RPO that the customer has chosen. So that gives the customer a very quick way to get those initial synchronizations done without incurring a heavy hit on their WAN link between the two sites. So once you're up and running and you've chosen your RPO, and I would guess, without wanting to kind of presume anything for the people listening, I would dare say that most people listening are like all of my customers of any size, that if I asked you what your unique write rate is of your virtual machines, you would probably have no clue at all, and that's absolutely expected. Nobody really kind of tracks that data, and we certainly don't provide a metric at the moment to allow you to track that data. But that is what will matter to your rate of change of data for the virtual machine per day. So when you configure your RPO value, let's say you set it to 15 minutes as an example, then if your WAN link is not capable of supporting that kind of RPO based on a rate of change, then it doesn't mean the replication won't occur. It just means you'll get lots of warnings in the UI to say you're not hitting your RPO target. So why might that be? That might be because you've set a 15-minute RPO, so you're kind of saying to the system, I'd like you to try and let the data never get more than 15 minutes stale, target site. But my rate of change of data is a lot higher than I thought it might be. I thought it might be 1 gig per day over the whole day. It's actually 100. Now, if you're in that situation, you're obviously going to be, when you divide the day up in minutes and synchronization windows, you're probably going to find that the size of each transfer is so big that the system and the infrastructure can't support it across the WAN in sufficient time for it to complete before the next window kicks in and it's trying to start on the transfer. So that's not a problem. You're just going to get messages in the UI that say, you've set a 15-minute RPO. On average, each time I'm snapshotting this virtual machine, it's taking me 25 minutes to transfer the image. What that tells you is simply two things. You either need to put in a bigger link between the sites, or you need to lower your expectations on what RPOs you can achieve over your given link. So you could get very complex on size. You can get quite simplistic, and sometimes quite simplistic works very well because you can maybe set your expectations. Maybe you would like to achieve a 15-minute RPO, but you've already got suspicion that the one link you've got between them might only sustain a 1 hour or a 2 hour RPO. And the system will validate that quite quickly once you start doing transfers. And there will be a more detailed white paper that you can go and download within the next 4 weeks, which kind of goes into this in a lot more granularity, since those that are interested.
We'll be plugging that white paper at the end of the broadcast here. So I love the idea of being able to initially seed that copy, Lee, and a Drobo is a perfect device to do that seeding. It's a small box, provides a lot of big storage, and will help you in case there's any hard drive failures that occur while you're transporting it between the two sites. So Drobo can help you out with that as well. Going over the putting it together slide here, if you want to do replication for VMware, it's built into Site Recovery Manager, and as long as you have vSphere 5 Standard Edition licenses or greater, you can have enterprise licenses or other licenses there, you can use Site Recovery Manager. It's not yet currently available for Essentials or the Essentials Plus kits, but Lee, do you think that might come one day, or for now, folks should assume that standard is the minimum?
For now, I would assume standard is the minimum. It's something that we're constantly reviewing, so if you've got feedback on that, please, whoever or however you purchase your VMware licenses, then please, they will have a communication channel back into VMware, so please communicate that back. We review the kind of the pricing and packaging on a fairly regular basis to make sure that it's reflective with what the market wants. So please let us know if you think that's something that we should be doing or shouldn't be doing.
Well, certainly $195 per VM is more than reasonable. It's a fantastic price to get this level of protection and orchestration for replication between sites. So the minimum quantity on those licenses is 25, so just shy of $5,000 US for the software. You can get a business grade Drobo SAN storage device, or 12-bay SAN storage for business with 12 terabytes for $12,000 US approximately, and it's great for your recovery site to complement an existing SAN you have at your protected site, or buy a Drobo for both sites and set up this type of replication, leveraging the replication services that are built into VMware. As we've discussed during this presentation, manage it centrally there so you don't have to become an expert in storage technologies. You can create your recovery plans and manage all of that from VMware, where you're likely, as a small business IT person, spending the majority of your time making sure that your applications are up and running and make sure they're running well for your users. It's time for our question and answer now. And the first question to you, Lee, would be for customers who are really limited just to one site. They're looking at the trade-offs between building a second site or having IT kit at a second site versus the cloud. Is cloud an option where you can have it as your recovery site? Where's the industry as far as that's concerned?
Yeah, so that's always, I guess cloud from a DR point of view is maybe traditionally been called DR as a service, and that's certainly been available for a while now, but it's been purely based on SAN replicated solutions. So things like vSphere replication make that a whole lot more flexible for the providers to start an offer. So I would expect to see, and certainly in the VMworld in Vegas, we announced a program called DR for the Cloud, which is based around a number of existing providers providers, most of which are in the US, companies like hosting.com and Ireland, who are starting to build out vSphere replication services based around SRM and disaster recovery. So, you will start to see that market grow quite rapidly over the next few years. So, that if you don't have a second site, then that's definitely a possibility. The one thing I just wanted to say about the previous slide is that the licensing requirements for 75 virtual machines, that is actually per site. So if you do have a second site or office where you're going to put like a Drobo unit in that office, then if you want to run production VMs with the SRM standard edition license, the $195 per VM license, you're entitled to run 75 per site, physical site. So you can actually do 150 total between the two sites if you think about it in that context. So that's one thing I wanted to make clear. It's not 75 total across the two, it's 75 each. So you can do that as well.
We have a question here that came in over the internet. In terms of iSCSI, will this work with ESXi and earlier Drobo equipment, or is this something that requires the latest software from VMware? And I can confirm that from putting the solution together, vSphere replication specifically built into version 5 and SRM version 5, and the requirements would be to have both of those running at both sites. And from a Drobo perspective, all you need to do is have an iSCSI capable Drobo. We are picturing our B1200i, our latest model SAN storage for business, but our 8-bay SAN storage for business could work just the same. Our recommendation on sizing would then be based on the load of your VMs and how much performance you needed for each one of those and any other special high availability you needed for those applications. But with vSphere replication, it is something that is independent of the hardware, so you can use any iSCSI capable Drobo that we have for business. Lee, I have a question for you. In terms of what you're seeing people do, are folks looking to upgrade to vSphere 5 to take advantage of these capabilities? And is this one of those things that people should look at when considering going from 4.1 to 5.0? What's your expert opinion on when the right time is to change from your 4.1 implementation to 5.0?
Yeah, I mean, if we go on the past releases like vSphere 5 and vSphere VI3 as we called it, the usual upgrade path that most customers take is they'll upgrade Virtual Center first. They'll get the management framework upgraded to the latest version, and they'll kind of let that bed in for a couple of months or weeks. And then people will start to upgrade the hosts, usually because I guess people are, who've been in the industry a while are very cautious about doing what is essentially the equivalent of, I guess, an operating system upgrade, even though hypervisor is not the same as an operating system. But I guess there's always that mentality of nobody wants to be seen to be the first person to upgrade their version, although, believe me, many customers do it straight from the immediate GA date, and the second it's on our website. But when you look at vSphere replication, it's obviously one of the compelling reasons, I guess, which is maybe driving more people to upgrade ESX quicker than they potentially would have done in the past, because now this is if the VMs were running absolutely fine on 4.1, they may have felt comfortable sitting on 4.1 ESX for a little while whilst they ran Virtual Center 5, but now they know that if they want to use vSphere replication or any element of it, they must have ESX5 hosts at both sites. So we're certainly seeing a lot of traction in terms of people upgrading hosts more aggressively than they may have done with the previous, VI3 and vSphere 4 releases. So, that's definitely been a big change in version 5.
Hey, the last question, Lee, and I really appreciate you taking time with us this afternoon, your time, to talk on the Drobo Broadcast Network, would be around test and dev versus production. We're showing all of our examples here that are assuming there's two physical sites, but would this same technology be an approach to having, let's say, a campus environment which wouldn't protect from a natural disaster, but would provide a lot of the protection you'd have from other types of outages? Would you use this with two different vCenter instances in the same campus, but at a short distance? Or really is vSphere replication and SRM mostly something that people would consider doing for sites that are separated by a large distance? How do you normally consult with customers around that question?
Obviously vSphere replication is asynchronous, so asynchronous normally lends itself to replicating over a very large distance, which is obviously different. Synchronous implementations are usually 100 kilometers Yeah, if a customer said to me, we want to do a vSphere replication or even a SAN replication environment between two rooms or data centers that are very close together, geographically speaking, and maybe supplied and serviced by the same power company, and utility provider, then you might ask a few questions around, what is the logic behind that? Because if the two rooms are being supplied and powered by the same company on the same campus, then if one goes down, the other one's potentially likely to go down as well. But if the customer comes back with a strong enough argument why they want to use the DR tools for that, if you like, like SRM vSphere replication, then by all means we have customers that do that. I mean, traditionally they may be looking at a campus, stretch storage solution, maybe more of a fit for them in that environment. But if they say no, there's enough justification to have a replicated solution between a short distance because it gives us the orchestration element. We like the fact that we can test the failovers offline, and it allows us to stand up the applications in almost a bubble, so we can do some testing and sanity checking in isolation from production very easily. Then we've seen that adopted as well. We've got a number of customers that they maybe are less interested in the DR aspect of SRM and more interested in the fact that it can stand up a copy of their environment very quickly off a storage snapshot at a remote location that might only be literally meters away, because it solves an operational problem for them, the fact that it can do that. You kind of have to look at all sides of it. Traditionally, if the data centers are very close together, that's a stretched solution rather than a DR solution. But if the DR solution in that use case solves other problems for you, then by all means you can still do it.
One of the last questions that snuck in that I'll address is that SRM supports several different topologies. The example we gave was the most basic one with a protected site and a recovery site, but there could be many sites and they could be multiple directions or many to one, lots of different information there. You can find out a lot more by that link. We have a Site Recovery Manager evaluation guide that's linked here at the bottom of the slide. There's also a published book on Site Recovery Manager, which was promoted at VMworld, and you would be welcome to check that out as a resource. You talked about that new white paper that's coming out, Lee. Maybe as you provide your closing comments, where would someone go look for that particular white paper once it's available?
So if you just go to VMware.com onto the documentation page, which is off our corporate homepage, it'll be available there. There's also a blog that we have called blogs.vmware.com/uptime, which we post a lot of information on around things like vSphere replication, SRM5, different tips and tricks for using it and customizing it. So there's already some information up on the blog around bandwidth sizing. So by all means, search for that on Google. Just search for blogs.vmware.com and word uptime, and you'll find your way to that very simply. So keep a look out for that. And also the SRM product itself is available as an eval, so you can download it with a built-in license key. So if you want to play with vSphere replication and you want to play with SRM5, then obviously make sure you've got vSphere 5 first on your hosts, and Virtual Center 5, because you need those two if you're going to use vSphere replication. And then find your way to the SRM eval page, and you can download the product itself, and you can play with it.
Fantastic. I really appreciate your time and your expertise today, Lee. And I thank everybody for participating. If you want to get the how-to guide on how to use Drobo with SRM Site Recovery Manager version 5, you can get that from the Drobo site as well on that link. Thanks, everyone, for joining, and we'll see you next time on the Drobo Broadcast Networks.